In this video, we're going to work some example problems related to the graphs of the sine and cosine functions, also known as the sinusoids. Remember, the graph of both sine and cosine are both referred to as sinusoids. So as we go through these problems, you might be wondering, well, haven't we already kind of answered these questions? For example, we already know what amplitude is. We already know what period is. Why are we working these problems, answering these questions? Well, what's really going to help you to retain what you're learning in this course, absorb it, inherently understand it, is the repetition. Repetition of example problems, repetition of answering questions, repetition of just watching lecture videos on topics. That's why I don't mind repeating the same things in different videos, teaching the same concepts in different videos, but from different perspectives, or going through questions like, for example, these fill-in-the-blank questions about topics that I've already lectured about and that we've already answered questions about. You know, we haven't done any fill-in-the-blank problems yet about the graphs of sine and cosine. So this is all really good repetition to help you to retain what you're learning here. Okay, the amplitude of the graphs of the sine and cosine functions is what? And the period of each is what? So they're referring to the definition of sine and cosine. So like, yeah, any random sine or cosine function, you don't know what the amplitude is, but they're referring to the sine function and the cosine function. What is the amplitude of the sine and cosine function? Well, we know it's 1. And the period we know is 2 pi, 1 full rotation around the circle. For the x values 0 to 2 pi, the graph of the sine function rises or falls, and that of the cosine function rises or falls. Okay, 0 to 2 pi, you're going, that's the first quadrant. So we know that sine is y over r, it starts at 0 and then increases to having y equal to r in the first quadrant. So it increases from 0 to 1 in the first quadrant, so it rises. And cosine starts at r is equal to x. It starts at 1 and then it decreases towards 0. So the cosine function falls, going from 0 to 2 pi. The graph of the sine function crosses the x-axis for all numbers of the form what, where n is an integer. Okay, so the graph of the sine function, we know it starts at 0 and then does like this over a full period, this is 2 pi. Okay, and then a feature of all sinusoids is that these key points, this point, this point, this point, the x-intercepts and the peaks and troughs are all equally spaced across the period in all circumstances. Like, in other words, no matter how the sinusoid is transformed in any way, that's still going to be the case. So the sine function, they're asking about these x-intercepts here in this question. So this is at pi over 2. This is halfway. This is at pi. This is at 2 pi. This is at 0. So it's in pi, because n could be anything. It could be 0, 1, 2, negative pi, negative 2 pi, negative 3 pi. That's going to be the x-intercepts. So in pi. The domain of both the sine and cosine functions in interval form is what, and the range is what? Yeah, okay, so the domain of the sine and cosine functions we know is all real numbers. There's no issue at like a quadrantal angle. It's absolutely any number. And the range we know, we answered this in the first question. Well, not really. We talked about the amplitude, but the range we know, it's -1 to 1, including -1 and 1. You can input no matter what, any number from negative infinity to infinity, you're going to get something in this range. The least positive number x for which cosine x is equal to 0 is, so the least positive number. Okay, so we think about the definition of, again, so the least positive number So cosine is 0 at the vertical because x goes to 0. Cosine is x divided by r here. Okay, so when you get to 90, it's 0, and when you get to 270, it's 0. And then, 270 plus 180, and then that plus 180, or you can go in the negative direction, but they're saying the least positive, so it's going to be 90. Or, well, no, that it's in radians, it's pi over 2. On the interval pi to 2 pi, including the endpoints, the function values of the cosine function increase from, so now we're going, they're referring to this, this is the second and third quadrants, right? So, okay, x. So the cosine, x divided by r, right, cosine theta, going through the second and third quadrants, cosine starts at, with x, negative x equal to r, so it starts at -1, goes to 0, then goes to 1. So yeah, it increases from -1 to 1. Right, at pi, you have x is equal to r, but x is in the negative direction. So it's negative, so cosine's -1, and then it going to 3 pi over 2, x goes down to 0, and then going to 2 pi, x increases towards equaling the radius, which that means that x divided by r is 1. Okay, let's match each of these functions with the graph that it corresponds to. All right, so there's no horizontal or vertical shifting. Really, we would be more concerned about horizontal shifting because then we're going away from the fundamental definition of sine and cosine at that point. So, okay, we can think about some of the things we can think about. We know that since we're not shifted horizontally, we know that cosine is going to start at the origin at an amplitude. If it's not flipped, it'll be the positive amplitude, but we could have some flipped here. Okay, and sine starts at 0. Okay, so let's see if we can use that fact to narrow some things down, or maybe identify a graph, a function with its graph. So, okay, we've got 3 sines and 3 cosines, and we've got 1 negative sine and 1 negative cosine. So we should be able to match these up here. So let's see. Well, maybe not the negative sine, because negative sine and positive sine are going to start at the same place at 0. So we should be able to find the negative cosine. That would be this here. So yeah, that's D. And actually, we could identify negative sine because negative sine, yeah, negative sine and positive sine both start at 0, but negative sine is going to be flipped. So normally sine does this, but negative sine is going to do this, and it'll be the only one doing that. Kind of like this is the only cosine that's starting at a negative amplitude. This would be the only, even if the sine here, the periods change, here the amplitude of the sines change, but still, these aren't flipped. They're going to be starting like that from the origin. So that means this would be negative sine. Has to be, because there's no other negative sine in this list. Okay, now we've got a sine and a cosine with periods adjusted. The periods are decreased by 2. So a standard sine and cosine with amplitude 1, just their periods cut down by 2, so the period's going to be pi. So here we have a period pi, we can see, and this is a sine. Okay, where else do we have a period pi? Here we have a period pi, and this is a cosine. Okay. So now we've got 2 left, and these both have amplitude 2, which is what we expect. And they're just standard sine and cosine with period, or no, these both have amplitude 2. Is that what I said? We expect both of these to have amplitude 2, and they do. And the period's just going to be standard period 2 pi. Now here's sine, and here's cosine. Okay, for each of these, we want to determine an equation of the form y is equal to a cosine bx or y is equal to a sine bx, and they're telling us that b is going to be greater than 0, so we're not doing any flipping about the x-axis, which we could. We did work examples in the previous videos where we did flip about the x-axis, just strictly no translations horizontally. I mean, vertically, we haven't done anything vertically too, but it's really horizontally because you've gone away from the definition of the sine and cosine, that's what we're focusing on right now. So, okay, if we look at this, we've got an amplitude 2 and a cosine. Okay, so the amplitude is 2, and we have a cosine, right, because cosine of 0 is the amplitude value. Well, it's cosine of 0 is 1, but if you multiply out front with 2, then the function will be equal to 2. Okay, the period we can see is pi. Okay, so that means that the original period has been cut in half. It went from 2 pi to pi. The period of cosine was cut in half. The period of cosine is 2 pi, and it's been cut down to pi. So we're going to multiply by the reciprocal of that. When you cut down by 1/2, that means you're multiplying by a factor of 1/2. So we're going to multiply the x variable by the reciprocal in the function. So we're going to have y is equal to 2, which scales the amplitude up, and then cosine 2x. Right? We have cosine. We started with basic cosine. You can see this is not flipped or anything. We scaled the function up by a factor of 2. So now, like cosine of 0, if you plug in x is equal to 0, cosine of 0 is 1, and you get times 2 is 2. So the amplitude is 2. But then, since we multiplied the x variable by 2, that means we're scaling by the period, the x-axis, the function by the x-axis, which is related to the period, by a factor of the reciprocal of that. So we're multiplying the period, which was originally 2 pi, by 1/2, which makes the period pi. So this is 2 cosine 2x. Okay, here we've got another period pi, so we're going to be multiplying the argument in the sine or cosine function by 2. So the period is pi. Okay, the amplitude is 2. Okay, now, and we can see we're starting at 0, so this is a sine function, but notice that we're not starting like a typical sine function, which would start this way. We're starting in the opposite direction because it's been flipped about the x-axis. It can't be flipped about it's flipped about the x-axis. It can't be flipped about the y-axis because they're telling us the b is going to be positive. The b is we can't multiply the x by anything negative, but a can be negative, and it is. The amplitude is 2, but the function is going to be y is equal to minus 2 sine 2x. Okay, here, this is a little bit tricky because what's the period here? Is this a cycle? Well, no, they're showing us we can extend this. Okay, this is a half of a cycle. What they're showing us here is a half of a cycle of a cosine that's been flipped because we're starting at 0, we're starting at the negative amplitude. So the amplitude is 3. Now, what is the period? Well, we can see it's not 2 pi, it's 4 pi. Okay, so what does that tell us? That tells us that with cosine, just the definition, the period is 2 pi, so the period has been scaled up by a factor of 2, which means that the x variable in the equation has been multiplied by the reciprocal of 2. So we're going to get y is equal to minus 3 and then cosine of 1/2 x. That means we've stretched about the reciprocal. That means we multiplied all the x coordinates by the reciprocal of this. So we've stretched it out by 2. Okay, here we can see it looks like the same problem as previous, but now it's a non-flipped cosine function. The period is 4 pi. This is cosine, so yeah, it's just 3 cosine of 1/2 x, but it's not flipped this time. Okay, we can see the amplitude is 3, and this looks like a non-flipped sine function. Okay, now the period, 1 full cycle, is pi over 2. Right, that's 1 full cycle. Now, what does that mean that the original period was multiplied by? So we had, it was some number, I'll say z, so we had 2 pi, the original period, was multiplied by some number, and we got pi over 2. That's what this came out to, pi over 2. So what was this number? Well, z is equal to pi over 2 times, and then 1 over 2 pi, so z is 1/4. So that means that this was scaled about the x-axis. It was shrunk by a factor of 1/4, or by a factor of 4. It was shrunk by a factor of 4, which means all the x variables were multiplied by 1/4, x coordinates, and the period was multiplied by 1/4. So in the equation, we're going to be multiplying x by the reciprocal of this. So, okay, it's 3, and we got sine of 4x. Okay, let's see. Amplitude is 3, and it looks like we have a flipped cosine because we're starting at -3. So it's going to be a cosine, and then its 1 cycle is pi over 2. So the period is pi over 2, which we saw that means in the previous problem that means that you multiplied the original period 2 pi by 1/4. So we've got y is equal to -3 cosine of 4x.